Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0703, indicates a malfunction in the brake pedal position switch, NC, for the Honda CR-V model of 2023 and beyond. This switch is crucial for ensuring that the vehicle's braking system responds accurately to the driver's inputs. If this switch fails or indicates incorrect signals, the Powertrain Control Module, PCM, detects the inconsistency and logs this DTC. The PCM oversees several vehicle functions, including the engine and transmission performance, and relies on signals from various sensors such as the brake pedal position switch. When the vehicle is equipped with electronic systems like adaptive cruise control, this switch's accuracy becomes even more critical. Located near the brake pedal in the vehicle's footwell, the brake pedal position switch is typically a simple device that detects whether the brake pedal is pressed or not. A malfunction here can trigger a series of issues affecting vehicle safety and performance, warranting immediate attention. The brake pedal position switch plays a crucial role in the vehicle's braking system by signaling to the Powertrain Control Module, PCM, whether the brake pedal is engaged or released. When functioning correctly, this switch sends a signal to the PCM, allowing the system to manage braking functions properly. However, if the signal from this switch is inconsistent with the actual position of the brake pedal, the PCM identifies this as an abnormality, logging DTC P0703 as a warning. The switch is typically found in the footwell near the brake pedal assembly, making it accessible for inspection and testing. Faulty signals can result from various factors, such as wiring issues, misalignment of the switch, or an internal failure of the switch itself. Ensuring the brake pedal position switch operates effectively is critical for both the driver's safety and the vehicle's overall functionality. Several potential causes may lead to the occurrence of DTC P0703. A common cause is a faulty brake pedal position switch itself, which may fail to send the proper signals to the PCM. If the switch's internal mechanism fails, it may not signal whether the brake pedal is pressed or released, leading to discrepancies in vehicle braking operations. Additionally, there could be open or shorted wiring issues within the circuitry leading to and from the switch to the PCM. Such wiring faults can disrupt signal transmission, causing the PCM to misinterpret the vehicle's braking status. Another possible factor is the malfunction of the PCM's internal circuits, which may fail to process the signals properly. It's crucial to conduct a detailed inspection to accurately pinpoint the root cause of the problem. When DTC P0703 is stored, several symptoms may manifest throughout the vehicle, indicating potential issues. A prominent symptom is malfunctioning brake lights, which may not illuminate when the brake pedal is pressed if the switch is faulty. Furthermore, drivers may notice an inconsistent response in braking, which could compromise safety and driving performance. Additionally, since the switch is involved in various electronic functionalities, issues with cruise control might arise, leading to undesired acceleration or difficulty in deactivating cruise functions. These symptoms highlight the critical nature of the brake pedal position switch in maintaining safe vehicle operation, and thus require immediate diagnostic inspection and repair. As the first step in troubleshooting DTC P0703, start by turning the vehicle to the on mode position, which activates the electronic systems without starting the engine. This setup allows a preliminary check of the vehicle's diagnostics and monitoring systems. Next, utilize the Honda Diagnostic System HDS to examine the value of the cruise brake switch and idle stop switch during brake pedal operation. Press and release the brake pedal while observing the HDS data. The value should change accordingly if the system is functioning correctly. If the value remains static and does not reflect changes in the brake pedal position, it indicates a likely fault either within the brake pedal position switch or in the circuitry involved. This initial step is critical for confirming the presence of a fault before proceeding to further inspection and testing. In this step, we will conduct a thorough inspection of the IG1 ACG circuit and the associated brake switch and ground, BKSWNC and GND circuits. Begin by disconnecting the brake pedal position switch connector, which is an 8-pin, 8P connector, to prepare for circuit examinations. Following this, inspect the IG1 ACG circuit for proper voltage levels. When the ignition is set to on mode, a healthy circuit will show a reading close to 12 volts from the battery. Any deviations could indicate a problem within the circuit that requires further exploration. After assessing the power circuit, check the BKSWNC and GND circuits for continuity and any potential disruption, keeping in mind that these circuits should exhibit minimal resistance. Identifying faults in these circuits can confirm whether the signal output from the brake pedal position switch is compromised. During this troubleshooting step, focus on a thorough inspection of the brake pedal position switch. Before disconnecting the PCM connector, ensure to jump the SCS line using the HDS to maintain the vehicle's diagnostic integrity and wait for at least 1 minute. After preparing the vehicle, disconnect the PCM connector, specifically connector A, which consists of 50 pins, 50P. Once disconnected, test the brake pedal position switch by observing the signal being sent during brake pedal operation. The expected result is that the switch should toggle between approximately 0 volts and 12 volts as the brake pedal is pressed and released. Any continuous reading or failure to switch indicates the brake pedal position switch may be defective, necessitating replacement or adjustment. This inspection allows technicians to isolate issues directly attributed to the switch before moving on to the next troubleshooting steps. In this final troubleshooting step, we analyze the powertrain control module, PCM, for any underlying issues. If previous inspections have indicated that the brake pedal position switch and associated circuits are functioning correctly, the PCM is the next viable suspect in this problem chain. Initially, ensure the other components are confirmed to be operational. If so, any abnormal behavior could be attributed to a failure within the PCM itself. A faulty PCM may not process signals correctly, leading to issues like the one indicated by DTC P0703. Technicians will focus on conducting specific tests to evaluate whether the PCM is indeed the cause, often involving rechecking all previous connections and conducting thorough diagnostics to ensure that all circuits are intact and functioning normally. To ensure successful repairs have been made, the final verification process involves clearing any stored trouble codes from the vehicle's diagnostic system using the Honda Diagnostic System, HDS. After clearing the Diagnostic Trouble Codes, DTCs, it is vital to perform a comprehensive road test of the vehicle to evaluate the repair's effectiveness and gauge if any errant codes reappear during normal operation. During this road test, pay close attention to the braking response at various speeds and in different conditions to confirm that the brake pedal position switch is now functioning as expected. A successful road test should yield no new fault codes, and the brake lights should operate correctly without any delays or inconsistencies. Once verified, document the steps taken and confirm that the vehicle is operating safely and smoothly, allowing the customer peace of mind. To prevent issues related to the brake pedal position switch, it's advisable to engage in regular preventive maintenance for the vehicle's braking system. Technicians should conduct regular testing of the brake pedal position switch during scheduled services to ensure functionality before problems arise. Additionally, inspecting the wiring and connectors for any signs of wear, corrosion, or even fraying can help mitigate future faults. Ensuring proper alignments during servicing can be beneficial as well, as mechanical adjustments may impact switch performance over time. Regular maintenance not only ensures safety, but can also enhance the longevity of the braking system, reducing the likelihood of unexpected failures. By keeping an eye on these components, drivers can enjoy smooth and safe braking responses. In conclusion, DTC P0703 is an important diagnostic code that signifies issues with the brake pedal position switch in the Honda CR-V 2023 and newer. Understanding the critical role this switch plays in ensuring effective braking response and communication with the PCM reflects the importance of addressing this code promptly. Following a thorough inspection and testing strategy, including checking circuits and the switch operation, gives technicians a clear path to diagnosing the problem accurately. Oracle preventive maintenance practices can further reduce the risk of encountering this DTC in the future, emphasizing the significance of regular vehicle checks. Ultimately, being proactive about vehicle maintenance and addressing DTCs can improve overall safety and vehicle lifespan, providing both peace of mind and reliable driving experiences. Please like and subscribe to the channel. See you next time.